Hi everyone, today we're going to be going over how to find the volume of a cylinder. Okay, it's going to be our first shape of many when we're introducing this volume concept. So what is a cylinder? It's a three-dimensional object with identical circular bases, meaning the base on the top and the base on the bottom, it's the same exact size. Okay, and then it has the same cross section from one end to the other. We'll talk about what that looks like in a bit. So here are some examples of what a cylinder is, or what it looks like. These are all different types of cylinders. Then we're going to have to ask ourselves, well, what's volume? Volume is the amount of space that's occupied by a three-dimensional object or a region of space, expressed in cubic units. It has the same cross-section from one end to the other. So there's that word cross-section again. So here we have a can, right? A metal can, and if you want to think of what volume is, this is a metal cylinder. Volume is, if I poured water into the cylinder, how much water could it hold? That's essentially what volume is when you're trying to solve for that. So a cross section is if I had took a really sharp, I don't know, like a ninja sword or something, and I would cut it straight through the cross section from top to bottom. It's the exact same thing. Okay, that's sorry, I'm not a very good artist here. There, it's a little bit better. Okay, that's a cross section. So it says to find the volume of any shape, you multiply the area of the base times the height of the shape. That's it. It's real simple. Okay, so we got to find the area of the base, so the area of a circle, and then how high is it, right? Okay. Oops. Wrong button here. Bear with me. Okay. So this is the net of a cylinder. Okay. Basically, I want to let you guys watch this video. Hopefully the sound is going to play for you and come out on your end. And if it doesn't, you can go through to this slideshow and find it on my Haiku page, and you can watch the video for yourself.
What do we have with us? We have a rectangle and two equal circles. This, in fact, is the net of a cylinder. So how can you fold this to form a cylinder? You can do it like this. So now we understand how to form a cylinder from its net. Let's now look at the cylinder and its net. Look at the breadth of the rectangle. This becomes the length of the cylinder. Look at the two circles. The two circles have now become the circular base and the circular top of the cylinder. Look at the length of the rectangle. The length of the rectangle is equal to the length of the circular top and the circular base of the cylinder. So now you understand the concept of the net of a cylinder, don't you?
All right. So it's a very good illustration of how the formula for the volume of a cylinder is found. Okay. Some reason this slideshow is not fully loading. Give me a minute here. Still getting stuck somewhere. Okay, so the volume of a cylinder is a formula right there. You take pi r squared, which, if you recall, pi r squared is the area of a circle. Okay, and then all you got to do is multiply it by how tall the cylinder is. Okay, so that its height. All right, make sure you write that down. That's how you get a volume of a cylinder. Okay. All right. Then let's look at an example here. It says if the radius of a cylindrical tank is 4 feet tall, or excuse me, the radius is 4 feet and its height is 7 feet, what is the volume of the tank, right? So the radius is 4 feet. The radius, if you recall, the radius is halfway from the middle of the circle to the very end of the circle. It's 4 feet. So it's 4 feet in any direction, right? So if it's going 4 feet to the right, it also goes 4 feet to the left, right? If you're looking at the entire distance from one side to the other, it's going to be 8 feet. And 8 feet is what we call the diameter, if you recall. Okay. So just know the difference between diameter and radius. A radius is just half of the diameter. It's just 4 feet. So we just plug it into the formula. Volume equals pi times r squared times height. Okay. And all you do is you just punch it into a calculator. Okay, so the important part is you got to plug in the correct number. Right, so r is going to be 4, the radius is 4, and the height is 7. Now I'll just pull up a calculator here. Oops, for some reason that's not showing up. Hold on, there you go. Nope, still not showing up. All right, well, let's do this. I'll do it on the side here, on my calculator that I have. So if we have 4 squared, that's 16. 16 times 7 times pi. So remember that commutative property is applies here, meaning it does not matter the order in which we multiply, because we're going to get the same answers. So pi times 16 times 7 is going to give me 351.86. I'll just round it to the nearest hundredths. Okay. Now, what's next is super duper important. It's 351.86. What units? Well, we're talking about feet here, right? And because it's volume, it's always going to be a cubic measurement, meaning it's to the third power. It's three-dimensional, so it's third power. Okay. So you have to make sure that you have the type of measurement, it's in feet, and then you got to have it cubed. All right. Let's move on to the next example here. All right. Why don't you guys go ahead and pause the video and try to find the volume of this one on your own using the exact same formula and the exact same steps that I showed you guys. Now, you absolutely may use a calculator. Okay, so pause it and come back when you are done. Okay, you should have substituted in 5 for your radius, because if the diameter is 10, that means the distance across the entire circle is 10, but you don't want the distance from the entire circle, you just want it halfway, so from the midpoint of that circle. So let me just be clear one more time. This is if you're looking at the very top or the very bottom of the can, okay? And then you have this middle point. This is your radius. It's just your halfway. It's your radius no matter which direction it's going. It's from the very center of the circle to any part of the outside of the ring part, if you will. Okay, so if that's my radius, if I double it, it is now my diameter, if I combine both of them, right? So this purple is the diameter because it's all the way across. Okay, I just want to make sure everyone's clear on that. Okay, so if that's 10 feet, the diameter, well, halfway is the radius is 5 feet, and then the height is 21. So I have pi times 5 squared is 25 times 21. And again, I just go to my calculator. I'm just going to do 25 times 21 times pi, and you get 1,649.34. And then what type of units is this? This is feet, so it's going to be feet cubed. Okay, you always want to round it to your nearest hundredths. Right, your nearest hundredths. Okay, let's try the next one. For some reason, these aren't loading. This one page is not loading. Slide 10. Well, I'll try to come back to that. A soup can has a radius of 5 centimeters and a height of 10 centimeters. what's the volume of the soup can if half a centimeter of space is left at the top of the can to allow for the expansion? Okay, so sometimes you might get a word problem like this, and to help you with a word problem, you should probably sketch an example. Okay, so I'm going to go ahead and sketch the radius of 5 and the height of 15. Okay, and this problem is basically saying if there's if a manufacturer is making a can of soup and it's 15 centimeters tall, right? 15 centimeters tall, and then the radius is 5 centimeters, right? So the radius is 15 centimeters tall. Well, the soup manufacturer cannot fill the entire can full of soup. It has to have a little bit of air at the very top, so it allows, so you can shake it around, you can hear it swish around. Otherwise, the can would explode when someone opens it, right, or squirts out. You don't want that. So at the very top, there is this half centimeter of air left, of space left. Okay, so how would you guys solve this? All right, go ahead and pause the video, try to come up with something, and then come back when you're done. All right, you should have found out that the radius is 5, right? So if your radius is 5, the only thing that's going to be a little bit different here is going to be your height. So let's just solve 5 squared. It's going to be 25. So pi times 25 times the height. Well, the height is 15. However, remember, you got to take off a half a centimeter. So 15 minus a half is going to be 14.5. So again, just punch all this into a calculator. It's not complicated. This is super easy because you have a calculator. The only problem is, the only challenging part is you got to memorize the formula. You got to know exactly, what the formula is. It might be easy now, but once we get into our third shape or the next shape, you might get it confused. So 14. Excuse me. It's you're going to get 1,138.83. I'm going to round that, and this is going to be centimeters. Is our unit, so it's going to be centimeters cubed. Okay, there you go. And that's how much cubic centimeters of soup we can fit in the can. Okay, go on to the next one. Oh, shouldn't be a closure problem already. A couple of problems aren't loading here, so let me try to see. For some reason this one is not showing up. I'm just going to delete this cake here because I think I had a picture of the cake and it just was slowing down the loading of this page. So you have a cake that has a diameter of 8 inches and a height of 6 inches. What's the volume of the entire cake? And then once you come up with that, part 2 says, cut it into 8 slices. What's the volume of each slice? Okay, so I want you guys to pause the video right now. Just sketch your own cake, and then try to find the volume of the cake, and then the volume of each slice of cake. Come back when you're ready. Alright, so here's my beautiful cake. If my diameter is 8 inches, I only want half of the diameter. Half of 8 is going to be 4, so the radius is 4, and the height's going to be 6 inches, right? So we have 4 squared, which is 16, times 6 times pi. It's going to be 301.59, and this is inches cubed. That's going to be the volume of the cake. Now, if I only want the volume of one slice of that cake, and if I'm cutting it into 3 equal slices, I'm going to take that amount and divide it by 8. And I should get 37.699, so we'll just call it 37.7 inches cubed. This is for the slice, one slice of the cake. Okay. All right, let's see if the other page will load now. Nope, still not going to load. This is a good problem, so I'm not sure why this is not loading. Awfully frustrating. Sorry, guys. So this is actually unit 10.1.1 in CPM. I believe it's 10.1.1. I'm just trying to zip through this here, so we cover volume pretty quickly. Okay, so for some reason, I don't know why this is not loading. I guess we'll try to come back to it. But our closure problem, I want you guys to go through your house and rummage through your pantry or find anything in your house that is a cylindrical shape, a cylinder. And then I want you to take a ruler, if you have a ruler around, and measure the radius and its height. Right? If you're not sure how to find the radius, or you think it's too difficult, maybe don't find the radius first. Go ahead and find the diameter first. Okay? And then whatever you get, divided by 2. That'll be your radius. And then find it in centimeters. You're going to use inches, go ahead, but I think centimeters is a little bit easier. And then find the volume of that cylinder. Okay? And then tell someone at home about your amazing new discovery on volume. Okay, guys, I'm going to try and go back to that other problem. Okay, I finally was able to bring it up in a different way. So this is our last problem. I want you guys to actually do this one on your own. It says to work with a partner. Obviously, you don't have a partner, so just try this. Looking at the two cylinders that are drawn here, which one do you guys think has a greater volume? And then explain your reasoning. Okay, maybe write it down. Why do you think the left one is bigger, or why do you think the right one is bigger? And then actually find the cylinder for each one of them and see if your prediction was correct. Okay, give it a shot and come right back. Alright, so there's the volume for both of them. You see our inputs of radius and height for the green and the red problems are different numbers, but if you actually solved it all the way through, you find that both are exactly the same. Right, exactly the same units. Oops. There you go. Alright, so one might look like it's bigger than the other to you, but they're not. They're exactly the same. Okay, guys, that wraps it up for today. Again, go try to find a cylinder in your house and find the volume of that shape if you haven't done so. And then that's it. I will see you guys next time. Have a great day. Bye.